A list is an ordered collection of data. To create a list, first you are going to provide a square bracket. Then inside of the square bracket, you are going to provide values separated by commas. So here we have creating a list. To create a list, all you have to do is provide a square bracket. Inside of the square bracket, you provide values, otherwise known as elements, separated by commas. So I can have 1, 2, 3, 4, and 5. So this is a list of numbers. I can as well assign this list to a variable. So I can have something like nums is equal to 1, 2, 3, 4, and 5. So this is a list. Now let me create a list of strings. Perhaps I can have something like colors. Here I'm going to have a square bracket. Inside of the square bracket, I'll provide the elements or the values that make up a list. So here we can have red, we'll have blue, and we can have yellow. So this is also another example of a list. Now let's create an empty list. So we have creating an empty list. To create an empty list, all you have to do is to provide an empty square bracket. So I can have something like nums is equal to just a square bracket. So this is an empty list. Now, lists are heterogeneous in nature, meaning that a list can contain values of different types. Here we have list of numbers. This is a list of strings. A list can have values of different types. So can have something like items is equal to 1, which is a number. I can have true, which is Boolean. I can as well have something like red, which is a string. And I can even include a list inside of another list. So I can have something like 1, 2, and 3. So as you can see, lists are heterogeneous. Heterogeneous in the sense that a list can contain objects of different types. And like I said before, a list is an ordered collection of values or elements. Now let's look at this example. We have nums equal to 1, 2, 3, 4, and 5. When we say ordered, we're talking about arrangement. Each element or each value inside of the list occupies a position, and this position is known as index. So the first item in a list has a position or the index of 0. The second one has the position of 1, 2, 3, and 4. Now let's look at how we can access elements in a list. Here we have accessing elements in a list. And to do this, we use a square bracket, otherwise known as slicing operator. Now let me remove this list and provide fruits is equal to, we'll have our square bracket. Here I'm going to have apple. I'm going to have orange. I'm going to have grape. And finally, we have cherry. Now, to access any of the elements inside of this list, all you have to do is to provide the location or the index of the item that you want to fetch. So if I want to get apple, I'll provide the position for the apple, which is 0. Now let's fetch apple. And here I'm going to have fruits is equal to, first I'm going to be providing the list, which is fruits. Then I'll provide a square bracket, otherwise known as the slicing operator. Inside of the square bracket, I'll provide the position or the index. So in this case, I'm going to provide 0. Now let me print out the fruit. So here we have print fruit, and if I run this program, it is going to display apple. Now, if I want to fetch grape, I have to provide the position or the index for the grape. So this one has the position of 0, this has the position of 1, and this has the position of 2. So here I'm going to change this to 2. Now, if I run this program, you can see we have grape. Now, if I want to fetch the last item, I have to provide 3. That is the position. So I'm going to change this to 3, then run the program. And as you can see, we have cherry. Now, if I try to fetch a non-existing element from the list, I'm going to run into an error. So if I enter 4 and run this program, you can see we have a traceback index error, list index out of range. What this means is that we're trying to access a non-existing element from our list. So try as much as possible not to try accessing element that is not existing in a list. So the first element has the position of 0, 1, 2, and 3. And this type of operation is called indexing, when you're trying to access element in a list using the positions or the index. Then we have what we call negative indexing. So here we have negative indexing. In our previous examples, we accessed elements using positive indexing. And positive indexing starts from 0. So the first element has the position of 0. But in the case of negative indexing, instead of starting from the left, we'll start from the right. So the last item has the index of -1. The second to the last has the index of -2. Now let's try this out. If I want to fetch the last item in this list, which is cherry, I'm going to have fruit is equal to, I'll provide the list, so which is fruit, then a slicing operator and -1. -1 means the last item or the last element in our list. Now let me comment out this. Now I'm going to print the fruit. If I run this program, it is going to display cherry. So if you want to access elements starting from the right side, you use negative indexing. So for grape, the position is -2. So I can change this to -2, and this is going to fetch the grape. If I want to get apple, this one is -1, -2, -3, and -4. So I'm going to change this to -4. If I run this program, it is going to give me apple. So if you want to access elements in a list, you can use positive indexing starting from the left. And the first element when you're using positive indexing is 0. But if you want to use negative indexing, you start from the right. So it's a matter of preference. For me personally, I use positive indexing. But there are times when it is necessary that you use negative indexing, especially when you don't know the number of elements in a list. For instance, looking at this list, it is obvious that we have 4 elements. So if I want to get the last element, I'll simply do 4 - 1. So 4 - 1 is going to get me the last element. So if I run this, you can see we have cherry. But in a situation whereby you don't know the number of items in the list, the easiest way to access the last element is -1. So this will also fetch cherry. If you want to fetch the second to the last item, you simply enter -2. So this is about indexing or accessing elements from a list. Now let's look at slicing. Slicing is a way of extracting all or a portion of a list. So let's say we have nums is equal to 1, 2, 3, 4, and 5. If I want to extract or fetch a portion of this list, I'm going to perform an operation called slicing. So let's say I want to fetch 2, 3, and 4. To go about this, I can have something like result is equal to, I'll provide the list, which is norms. Then I'm going to provide a slicing operator. Inside of the slicing operator, I'm going to indicate where I want the slicing to start. And since I want to fetch 2, 3, and 4, so I'm going to start by indicating the position for the value 2. So this has a position of 0, this has the position 1. So our start index is going to be 1. The first value that you provide when you are trying to slice a list or a sequence is called the start index. So this is our start index. Then after this, I'm going to provide a colon. Then I'll provide the stop index. Stop index is where you want the slicing to stop. So I want to fetch this, I want to fetch this, I want to fetch this. So here we have 1 as the position, we'll have 2 as the position, and then here we have 3 as the position. So but instead of writing 3, I'm going to do 3 plus 1, which will give me 4. What this means is fetch items from this list. That is, in this case, this list. Fetch items starting from the position 1. Here is position 1, all the way to position 4, excluding the item in the position 4. In other words, fetch me all the items starting from here all the way to this position, excluding the one in this position, which ultimately means fetch me 2, 3, and 4. Now let me print out the results. So here I can have print result. If I run this program, we're going to get 2, 3, and 4. If I change this to 3, what this means is that fetch me items starting from position 1 all the way to position 3. So what this means is fetch me items in the list starting from this position, which is currently occupied by 2, all the way to position 3, which is like this, excluding the item in position 3. In other words, fetch me 2 and 3. So if we run this program, we're going to have 2 and 3. So this is how we perform slicing. Now, if I want to fetch all the whole items in the list, I'm going to change this to 0. That is, our start index is going to be 0, which means fetch me elements in the list starting from position 0, which is this position. And I'm going to be providing the stop index. So we have 5 elements in this list. So you may be tempted to think that 4 is the stop index. If you enter 4, it will not fetch you all the whole items in this list. As you can see, we have 1, 2, 3, and 4. So if you want 5 to be included, you are going to change this value to 5. And like I said before, this means fetch me elements in the list starting from position 0 all the way to position 5. And currently in this list, we don't have any elements in this position. But because we're excluding the item or the element in position 5, we're not going to run into an issue. If you want to extract or fetch all the elements in the list, you simply have 0 as the start index. For the stop index, you are going to provide an index or a position just one above the last index in the list. So the last index in this list is 4. But because we want to include 5, we're going to do 4 plus 1. And this is how we arrived at 5. So if I run this program again, it is going to fetch all the whole items in the list. Now, another way of doing this is instead of providing 0, I can just leave it blank. This will fetch me items from the beginning all the way to the end. So if I run this, it will still fetch me 1 to 5. I can as well omit the stop index. I'll simply have just a colon. If I run this, this is going to fetch me all the elements in the list. Now I can decide to start from position 1 all the way to the end. So I can have something like this. What this means is fetch me elements starting from position 1 all the way to the end. So if I run this program, it will fetch me 2 to 5. Now let me change this back to 0 as the start index, and for the stop index, I'm going to have 5. Now we have what we call step. So I'm going to include another column and provide 2. So what this means is that I want to skip some elements while slicing the list. If I run this program, as you can see, we have 1, we skipped 2, we'll have 3, we skipped 4, and we'll have 5. Now, if I change it to 1, 1 is the default. If I run this program, it is going to fetch all the whole elements. So if you don't want to skip, there is no point entering the step value. But if you want to skip some values, you simply enter a colon and then provide a step. In this case, we'll have step 2. Now, if I want to skip 2 elements, I can change this to 3. Now, if I run this program, you can see we have 1, we skipped 2 and 3, we have 4, and we skipped 5. So this is how we arrived at this. So this is the start index, this is the stop index, and this is the step. Now let's look at how we can update or modify lists. First, lists are mutable. What this means is that you can modify the elements in a list. So let's say we have nums is equal to 1, 2, 3, and 4. I can easily modify any of the elements inside of this list. And to do this, first, I'm going to fetch or access the element. Then I'm going to assign it to a new value. So if I want to change this first element, which is 1, first I'm going to be accessing the element, which is nums, a square bracket, and the index. Now I'm going to assign it to a new value. So here we can have 100. Now let me print out nums before the modification. So here I can have print nums. Now after modifying the element, I can as well do print nums. Now if I run this program, you can see initially we have the first element to be equal to 1. Then after modifying the first element, we now have 100. So assuming I want to change maybe the third element, I can as well have something like nums, then the index is 2. Then I'm going to be assigning it to, let's say, 25. Now, if I run this program, you can see we have 25. So if you want to modify any of the elements, you access the element, then assign it to a new value. And this is what we mean when we say that lists are mutable. You can alter, you can modify, you can update a list after creating the list. Like I said before, a list is a sequence of values, and as such, we can perform loops or iterations on lists. So let's see how we can perform loops on lists. So here we can have loops or iterations. So we're going to use a for loop. But first, I'm going to have my variable. So we can have something like colors is equal to red. We can have blue. We can have white. We can have orange. To loop through this list, I can have for color in colors, then a colon. Now I can have print color. Now, if I run this program, it is going to display the colors. We'll have red, blue, white, and orange. Now, apart from using the for loop, I can as well use the while loop. And to loop through a list using the while loop, I'm going to start by initializing a control variable. So we can have something like count. And because the first element in a list has the index of 0, so I'm going to initialize count to be equal to 0. Now here I'm going to have while count is less than, I'm going to count the number of elements in our list. So we have 1, 2, 3, and 4. Shortly, I'm going to show you how you can use a built-in function to determine the number of elements in a list. So, but for now, we're going to do it manually. So what we have here is 4 elements. So in my while loop, I'm going to have while count is less than 4. So here I'm going to have color is equal to, I'm going to be providing the list, which is colors. Then I'll provide a slicing operator. And for the index, I'm going to be using the variable count. So here I can have count. Now I'm going to increment the count. So here we can have count plus equal to 1. Now I'm going to be printing out the color. So here I can have print color. If I run this program, it is going to display the colors. So what happens is that first we initialize count to be equal to 0. And as such, this is going to fetch the first element because during the first loop, count is equal to 0. Now here we'll display the color and increment the count. On the second loop, our count is going to be equal to 1. And as such, we're going to be fetching element in the position 1. This continues on and on until we loop through all the elements in our list. Now, instead of providing this value manually, I can as well use the built-in function len to determine the number of elements in the list. So let me comment out this. If I want to determine the number of elements in a list, I'll simply use the len function. This simply means length. When we say the length of a list or the length of any sequence, we're talking about the number of elements or the number of items in the sequence. So I can have something like number is equal to, here I'm going to have len. Inside of this function, I'll provide the list, which is colors. Now let me print out the number. So here we can have print number. If I run this program, it is going to display 4. So 4 is the length of this list. Now I can decide to include another color or another element. So we can have something like green. Now if I run this program, it is going to display 5. So you don't have to count the element in a list. You simply use the len function to determine the length of your list. Now back to our program, I'm going to remove this. I'm going to remove the comment. Now instead of using the raw value for here, I can change this to number. If I run the program, it will display all the items or all the colors in our list. So this is how we perform loops or iterations on lists.